Section 6.2, Solving Systems by Substitution. There are 5 steps to solving by substitution. The first step being solve for one variable in at least one equation if necessary. Sometimes this isn't necessary and it's already done for you. Step 2, substitute the resulting expression into the other equation. So if you know one equation, so let's say y equals 3x plus 2, you're going to take the 3x plus 2 and plug it in for y in the second equation. Step 3, solve that equation to get the value for the first variable. Step 4, substitute that value back into the original equation and solve. And step 5, write the values from steps 3 and 4 as your ordered pair x, y. First example, we've got y equals 3x and y equals x minus 2. In both problems, our equations are already solved for y, meaning that we know that y equals 3x and y equals x minus 2. But to find the real values of the variables, I'm going to take what y equals in this case for the top equation, 3x, and plug it in for y in the second equation. This creates my new equation, 3x equals x minus 2. Then I just want to solve this for x. So I'll subtract x from both sides. I've got 2x equals negative 2. I'll divide by 2. And I get x equals negative 1. So there's one value. Now to find y, all I have to do is plug this back in for x and solve for y. So y equals 3 times negative 1, which means y equals negative 3. So the ordered pair that is the solution to this problem is negative 1, negative 3. Example 2, we have the equation y equals x plus 1 and 4x plus y equals 6. The first equation already tells us what y equals. It equals x plus 1. So we're going to take what y equals and sub it in for y in the second equation. So we have 4x plus x plus 1 equals 6. And now we just want to solve this for x. Combine like terms, 5x plus 1 equals 6. We'll subtract 1 from both sides. We've got 5x equals 5. And then our last step would be to divide by 5. And so in this case, x equals 1. To solve for y, we'll plug this back in and see what y equals. So y equals 1 plus 1, so y equals 2. And so our ordered pair here is 1, 2. In the third example, we have x plus 2y equals negative 1 and x minus y equals 5. Neither equation is currently solved for a variable, but we can solve one for a variable. Let's say we want to solve this second equation for x. To do that, I'll have to move the y to the other side. So we want to get x by itself. So our second equation becomes x equals 5 plus y. Now I know what x equals, and I can take what x equals and I can plug it in for x into the first equation. So now my new equation becomes 5 plus y plus 2y equals negative 1. I'll combine like terms. I've got 5 plus 3y equals negative 1. I will subtract 5 from both sides. I've got 3y equals negative 6. And my last step, divide by 3. And so in this case, I get y to equal negative 2. So there's one value. Now I'm going to take y and I'm going to plug it back in here and solve for x. So in this case, x equals 5 plus negative 2, which means x in this case is a positive 3. So my ordered pair solution, 3, negative 2. Next example, y plus 6x equals 11, and 3x plus 2y equals negative 5. I'm going to solve the first equation for y or get y by itself so I can substitute into the second. And in order to do that, I'm going to have to subtract 6x from both sides, which changes my equation into y equals negative 6x plus 11. Now I know what y equals, I can take this value and I can sub it in for y in the second equation. So my new equation is going to become 3x plus 2 times negative 6x plus 11 equals negative 5. When you have a coefficient in front of the variable when you're plugging something in, it's always best to put what you're plugging in parentheses like this, because I'm going to have to distribute my 2 eventually when I go to solve this. So my next step, distribute the 2. So I've got 3x minus 12x plus 22 equals negative 5. Combine like terms, negative 9x plus 22 equals negative 5. Subtract 22 from both sides. We've got negative 9x equals negative 27. Divide by negative 9. And you get x to be 3. Now that I know what x equals, I'm going to plug it in order to solve for y. So I've got y equals negative 6 times 3 plus 11. Well, negative 6 times 3 is negative 18. Plus 11 gives us y equals negative 7. So our ordered pair here is 3, negative 7. In the next example, we've got 2x plus y equals 8 and 3x plus 2y equals 9. And so we want to solve one of these for a variable in order to be able to use substitution. I'm going to rewrite the first one, solving for y, so I can plug in values. So in order to rewrite this so y is by itself, I'll have to add 2x to the other side. So I get y equals 2x plus 8. So now that I know that y equals 2x plus 8, I'll take what y equals, and I'm going to plug it in for y in the second equation. So now I've got 3x plus 2 times 2x plus 8 equals 9. I'm going to distribute my 2. That's 4x plus 16 plus the 3x out in front equals 9. So 3 and 4x become 7x plus 16 equals 9. I'm going to subtract 16 from both sides. And I've got 7x equals negative 7. I divide by 7. And I'm going to get x equals negative 1. Now that I know what x equals, I'm going to plug it back in order to solve for y. So I've got y equals 2 times negative 1 plus 8. So 2 times negative 1 is negative 2 plus 8. So y in this case equals positive 6. So your ordered pair solution here becomes negative 1, 6. Alright, for this example, I recommend solving the second equation for x in order to use substitution. And in order to do that, you have to subtract 3y from both sides, giving you x equals negative 3y minus 7. Now that I know what x equals, I can take this value and I can sub it in for x in the first equation, giving me my new equation to be 6y plus 5 times negative 3y minus 7 equals 8. Then we'll simplify this. So we'll distribute the 5. That's negative 15y minus 35. Don't forget about the 6y out in front. Combine like terms, we've got negative 9y minus 35 equals 8. I'm going to add 35 to both sides. I get negative 9y equals 43. Divided by negative 9. and I get y to equal negative 43/9. And then to solve for x, I'm going to plug it back in and see what I get. Keep in mind that 43/9 is the same as negative 4 and 7/9. And so we're going to plug that back in to see what we get for x. Substituting it in for x, you should get 66/9 is what you get when plugging in for x, and you solve this for x, or it reduces down to 22/3. So your ordered pair becomes 22/3 and negative 43/9. Not the nicest problem, but we solved it. All right, here we have a story problem. AT&T U-verse has a $60 setup fee and charges $80 per month, and Time Warner has a $160 equipment fee and charges $70 per month. When will the cost be the same, and what will the cost be? So we need to set up our two equations, one for AT&T and one for Time Warner. So for this problem, I'm going to let months be x and total cost be y. So for AT&T, our total cost is y equals $60 setup fee plus the $80 per month. For Time Warner, your total cost equals the $160 equipment fee plus the $70 per month. So to solve this, we're just going to take what y equals in the first equation and set it, or replace it for y in the second equation, giving us the equation 60 plus 80x equals 160 plus 70x. And we're going to solve. So we subtract 70x from both sides. This gives us 60 plus 10x equals 160. We'll subtract 60 from both sides. We get 10x equals 100. Divide by 10. And we should get x to equal 10. Now to figure out y, we just plug it back in. And so in this case, y equals 60 plus 80 times 10. And we get y to equal 860. So that means after 10 months, both companies will charge the same, which in this case will be $860. The next one, you pay $22 to rent 6 video games. Gamefly charges $4 for new games and $2 for old games. How many games of each did you rent? So in this case, we need two different equations. One equation is talking about what you paid total for all of the video games, or what you paid. Correction. You need two equations. One talking about what you paid in money compared to the total number of video games bought. So let's think about this. Let's let x equal the old games, y equal the new games. So in this case, we've got the number of old games plus the number of new games equals 6 games. And now we'll talk about the money. Well, we know that 2 old games cost $2 and new games cost $4, and together, when purchased, you spent a total of $22. So these are our two equations, and we want to try to solve these. Well, to solve this using substitution, I want to first try to rewrite this equation. Let's say I want to solve it for y. So I'll subtract x over, giving me the equation y equals negative x plus 6. So I'm going to take what y equals, and I'm going to plug it in for y in the second equation. So now my equation becomes 2x plus 4 times negative x plus 6 equals 22. I distribute, so 2x minus 4x plus 24 equals 22. Combine like terms, you've got negative 2x plus 24 equals 22. Subtract 24 from both sides, you've got negative 2x equals negative 2, which means when you divide by negative 2 on both sides, you get that x equals 1. That means you bought one old game. And then if we bought one old game, then it's pretty obvious that we bought 5 new games. So 1 old, 5 new.